Hello, hello, hello. Uh, Good morning. This is Professor N.S. Gogre. Quickly starting lecture number 9, that is problematic soil, alkaline soil, saline alkali soil, and alkali soil. These soils falls under categories of salt affected soil. We have to study their characteristics and management. Okay. Let you know the first. What do you mean by problem soil? Problem soils are those soils which cannot be used for cultivation without adopting proper reclaiming measures, which cannot be used for cultivation without adopting proper reclaiming measures. Okay. So these problematic soils, owing to land or soil characteristics, cannot be used economically for crop production without adopting proper reclaiming measures. This is the proper definition of problematic soils. So there are 7 to 8 types of problematic soils, out of which worst and major category falls under the salt affected soils. In this saline soil, saline alkali soil, and alkali soil, these soils falls under the category of salt affected soil. Rest are acidic soils, calcareous soil, submerged soil, khar khajan soil, highly eroded soil, ravine soils, soil salt, steepy slopes. Okay. This means that we can use the soil for commercial crop production without adopting proper reclaiming measures. What do you mean by reclaiming measures? We will study the reclaiming measure in management of problematic soils. So first we let you know what do you mean by saline soil, saline alkali soil, and saline alkali soils. First, saline soils are non-sodic soils containing sufficient soluble salts to impair its productivity. Sufficient soluble salts. These are the salts of calcium, sodium, potassium. These salts impair its productivity, okay, due to certain chemical characteristics. Okay. What is saline soil? Which contain an electrical conductivity of greater than 4 decisiemens per meter and exchangeable sodium adsorption is less than 13 and exchangeable sodium percentage is less than 15, less than 15, and pH of soil is also less than 8.5. At 25 degrees centigrade is characterized as the saline soil. Then what do you mean by alkali soil? These soils are saturated with exchangeable sodium colloidal clay complex which contain electrical conductivity of greater than 4 dc7 per meter, exchangeable sodium adsorption ratio greater than 13, and pH greater than 8.5. And exchangeable sodium percentage is also greater than 15, is called as alkali soil or sodic soil. Okay. What are the characteristics of saline and saline alkali soil, or it is also called as saline sodic soil? Saline alkali soil, saline sodic soil contains appreciable quantities of salts of sodium, calcium, and sulfates, which affect plant growth. The characteristics mainly includes electrical conductivity greater than 4 dc7 per meter, exchangeable sodium adsorption ratio greater than 13, pH is less than or equal to 8.5 and exchangeable sodium percentage is greater than 15 are called as a saline alkali soil. Okay, after characteristics of soil, we want to study what are the formations of saline alkali soil, what are the characteristics which contribute to formation of these soils, particularly arid and semi-arid climate, poor draining capacity of soil, then high water table, overflow of seawater over lands, introduction of irrigation water, salts blown by wind, soil developing from natural materials which are saline. Excessive use of basic fertilizer like sodium nitrate, basic like which contributes to alkalinity in soil, and humid and semi-arid regions. These are certain characteristics which are contributing to formation of saline and alkaline soil. If saline soil is not reclaimed or cannot be properly managed, then it will develop into alkalinity and alkaline soil. If it is not again properly reclaimed or managed, it will develop into leads to become barren soil. If proper reclamating measures are not followed. Okay. Then for this we have to study what are the proper reclamating measures to use this problematic soil under cultivation. So this is known as a reclamation, that is equal to amelioration, that is equal to chemical methods for managing problematic soil. In this we include mechanical method, chemical method, and biological method. The mechanical method is allowed for only saline soil. Rest are used for sodic or alkali soil. Okay. Reclamation management. For saline soil, certain mechanical methods are followed for reclamation. What are they? We want to just know. Okay. The first point under mechanical method, which is flooding and leaching down of soluble salts. What do I mean by leaching? Leaching is equal to ponding of water on the surface of soil. Ponding means we have to give the pond-like appearance. Pond-like appearance to leach down certain salts below root zone to control soil salinity. Is called as a leaching, or it is also called as a flooding and achieved by draining. Okay. Then what are leaching requirement? Leaching requirement is equal to EC of applied water divided by EC of draining water. EC of applied water divided by EC of drainage water. Then second mechanical method we followed for management of saline soil is scraping of surface soil. Scraping of surface soil with the help of spade, kurpi, just to remove surface soil which is white in color. In case of saline soil, we have temporary cure and salinity develops again and again. This is the second method for management of saline soil. Then what are the different cultural methods used for management of saline soil? In this we include providing proper drainage. We have to open drainage channel at certain interval to lead down certain soluble salts below the root zone. Use of salt-free irrigation water. Salt-free, good quality water should be used for irrigating crops. We should not recommend use of canal irrigation because canal irrigation contains salts which are dissolved around the seepage areas. So it is a very salty water. Proper use of irrigation water. Decrease in amount of water in the soil, increase the concentration of soluble salts. Soil moisture should be therefore be kept at optimum level or filled capacity, beyond which it contributes to development of salinity. Next method, planting or sowing of seeds in furrow. That it should be come in minimum contact with zone of salt concentration and which do not affect germination. And use of acidic fertilizer. Fertilizers of acidic nature, ammonium sulfate should be used in soil and soil. And use of organic manures. The organic manure which contributes to high water holding capacity. When sufficient amounts of these manures are added, water holding capacity can be increased. Soil solution decreases and percolation rate increases, which helps to minimize these salts from keeping away with these salts from root zone. Then next cultural method is plowing and leveling of land. Then retardation of water evaporation from surface and certain growing of salt tolerant crops, which includes high salt tolerant crops, that is barley, sugar beet, cotton, etc. etc. Moderately salt tolerant crops, that is wheat, rice, sorghum, maize. And low salt tolerant crops are beans, radish, and white clover. Then next method for reclamation and management of alkali soil. Management of alkali soil, or that is sodic soil. Alkali soil cannot be uh, alkali soil cannot be managed by simply mechanical methods or cultural methods. Some cultural methods are followed, but no mechanical method is used for reclamation or management of alkali soil. In this, we use generally chemical methods. In this application of gypsum using iron pyrite, sulfur, dolomite, phosphogypsum, certain chemicals are used to reclaim or manage sodic soil. When gypsum is used as a chemical reagent, calcium replaces exchangeable sodium on clay complex and convert back the calcium clay into convert back to sodium dominated clay into calcium dominated clay. Why this? So calcium is able to replace the sodium. Sodium is one of the most dispersing agent. We disperse other elements and takes their place. I want to show by whiteboard. Normal soil that is contained with sodium dominated on K complex, sodium dominated on clay complex. This is the soil with the dominated is sodium on clay complex. Sodium. Okay. We have to add gypsum, that is calcium sulfate. CaSO4, that is CaSO4, which in this gypsum, calcium is the most dominated ion which replaces sodium on sodic soil. Why calcium replaces sodium? Because sodium is a divalent in nature. Sodium is monovalent in nature. Ionic radius of calcium is greater than sodium. That's why calcium replaces sodium on exchange clouds and converts back the sodium dominated clay into calcium dominated clay. This is the proper reaction. If sodium dominated clay complex, yes, sodium dominated clay complex, then it is gypsum. Okay. We have lost connection. Then we are quickly going to whiteboard. Slide share this screen and whiteboard. Whatever we have created has gone. Okay, I will just uh, replace again. This is the clay complex that is sodium dominated, which is has accumulation of sodium dominated clay complex. Then we have to add gypsum, that is calcium sulfide, CaSO4. Why we have used calcium sulfide? Because calcium is divalent in nature and has ionic radius greater than sodium, so it easily replaces sodium on exchange complex and converts sodium dominated clay complex into calcium dominated clay complex. Then what with the products of reaction are calcium replaces sodium. That is calcium replaces sodium on exchange complex. So this becomes calcium dominated clay complex. And plus Na2SO4. Na2SO4. We have to show this arrow that is known as a leachable, which leach these sodium salts that is sodium sulfate below the root zone. So it is the process of reclamation of chemical method for reclamation of alkali soil. Okay, I can go back or okay. Application of gypsum. Then scientist Kuhn has given gypsum requirement. What is the gypsum requirement? It is amount of gypsum required to be added to a sodic soil or alkali soil to lower its CSV, that is exchangeable sodium percentage, to a desired level. So to obtain normal soil, what is gypsum? Formula for gypsum requirement. Initial ESP minus final ESP divided by 100 into CEC is the formula for gypsum requirement. Okay. It is all about use of gypsum. What is use of sulfur? That is elemental sulfur or iron pyrite is added to reclaim soda. And what is biological method of reclamation of alkali soil? Organic materials, that is organic matter decomposer that like Trichoderma viride is used for decomposition purpose, which releases certain organic acids and lowers the pH of sodic soil. In combination with these, we use certain bioinnoculatant that is known as a Trichoderma viride, Trichoderma spiralaceae, that is used for reclamation. And we use certain bioinnoculatant that is known as thiobacillus thioxidans and thiobacillus peroxidans to convert back sodic soil to normal soil. And certain amendments, that is chemicals used for reclamation of sodic soil. That is first known as a soluble salts, that is gypsum. Then acid forming, that is sulfur, sulfuric acid, iron pyrites, and iron sulfates. This is all about reclamation of sodic soil or alkali soil. Thank you.